Welcome to our series on object-oriented programming. So we're going to be starting with a glance at programming paradigms. And what programming paradigms are overarching styles that shape the way that we approach coding. So they're going to be providing us with a guiding structure for designing, organizing, and for writing our programs. And there's going to be a variety of different programming paradigms that are going to be offering a unique perspective on how we can solve problems and carries with it specific tools for addressing those problems. So these paradigms don't exactly dictate the syntax of a language either, but it's going to be influencing how we organize and how we're going to be structuring our code. So there's going to be a few examples that we're going to be going over that are going to be a few common programming paradigms. So one's going to be procedural programming, which is going to be involved breaking down the program logic into a sequence of steps or procedures that's going to be much like a cooking recipe. So it's going to be very straightforward and it's going to go step by step through the process of the code. Then there's object-oriented programming. And in object-oriented programming, we're going to focus on creating objects which hold both data, which is the state, and functions, the behavior. And by creating these reusable chunks of code, which are going to be known as classes, that object-oriented programming is going to enable the structuring of programs in a way that models real-world entities. And we also have functional programming, and this paradigm is more akin to mathematical computation. It encourages the use of pure functions to avoid changing state and mutable data. And it's less about executing those steps and more about evaluating expressions. So then we have logical programming, which is going to be based on a formal logic. And this paradigm is going to be encouraging the expressing of logic of a computation without laying out the control flow. And finally, we're going to have event-driven programming. And in this paradigm, the flow of the program is usually influenced by events such as user interactions, sensor outputs, or messages from other programs. And you can think about JavaScript for this example. So first, before we dive into object-oriented programming, I believe that understanding procedural programming offers a very solid foundation. So at its core, procedural programming is about giving a list of instructions to the computer. So we can consider baking a cake. There's a specific series of steps to follow from, gathering the ingredients to baking and finally eating that lovely cake. And I'm going to be pasting this ordered list onto this VS Code just to give you an example of what it would look like. So we can see that this is a cake baking procedure that includes steps 1 through 23. So first, we're going to be gathering the cups of flour, the sugar, and we're going to gather all these ingredients. Then we're going to be preheating an oven. We're going to grease a cake pan. We're going to combine the flour, sugar, and get eggs, mix that into the bowl, butter, milk, vanilla, and then we're going to mix those ingredients. We pour the batter, put it in the preheated oven, we bake it, and then we test to make sure that the cake is actually cooked. Once we do that, we remove the cake from the oven. It might actually be best to remove it first, but anyways, then we're going to allow the cake to cool before serving, and then we're finally going to eat the cake. So as you can see here, this is a very straightforward guide to how you should bake a cake. And this is going to play exactly into how we're supposed to do procedural programming. So in the context of programming, let's look at some actual code in Python. And this code in Python is going to be calculating a student's final grade. And it's going to be following this very clear set of steps. It's going to take input for the student's of the student's name, and we'll do that right here. So let's replace all this. So we're going to get the student's name, which is Sarah. Then after that, we're going to be inputting the grades for different subjects that the student has. So we're going to have a math grade, an English grade, science grade, history, and a geography grade. And after that, we need to calculate the total grade. So the next step is calculating that, which just means adding all these grades from the math to the geography grades. And then after that, we are going to need to calculate the average grade. So we'll calculate the average by dividing by 5, and then we're going to determine the final grade. So in this example, if the average grade is above a 90, we get a final grade of an A. Else, if the average grade is above an 80, we're going to get a B. Otherwise, above a 70, a C, above a 60, a D, and then else, it's going to be an F. And finally, what we're going to want to do is we're going to want to print the final grade for the student. So we'll have a very simple print statement that we have here. And as you can see, if we decide to run this program, we're going to get the final grade for Sarah is a B. And this procedural code snippet is very straightforward, as you can see. But the issue is that, let's say we want to calculate the grade for another student. Well, what we're going to have to do is we're going to have to rewrite all of this all over again. And this is going to cause us to change the state of student name, the math grade, English grade, science grade, history, and geography grade, and so forth. So this is going to be a limitation that occurs in the procedural programming. And let's take a look at this example that includes 3 different students using this exact setup. So let's paste that right here. All right. So first, we're going to have someone named Joe. It's going to have their grades, calculating it, then printing it. But then we have to create another student name for Karen. We have to get their grades and so forth. And we're going to do it for Maddie too. We're going to have to recreate all these variables. We're going to have to overwrite them. And it's just a little bit of a mess, right? It's not very organized. And as if you can see, in the future, if we scale this to like 20 students, it's going to be over, let's say, 92 lines of code right now. So if we effectively multiply it by 6 or 7, that's going to come around to like around 500 lines of code for this simple little project. And basically, we don't want to do that. That's going to be very tedious for us. And this is actually where functional programming comes into play. So let's go over functional programming now. So functional programming is a paradigm that primarily emphasizes the evaluation of mathematical functions. So without altering that state or mutable data, kind of like how we kept overriding the student name, math grade, and so forth. So when we talk about mathematical functions, I really want to emphasize this is the concept that functions map specific inputs to specific outputs. It does not mean these functions have to be mathematical at a high level. It could return a string. It could return an integer. It can do an object. It can do anything. We're just trying to refer to the simple inputs that you give this function and how it gives an output, right? So we can consider a mathematical function right here. And this is actually going to be math, just to make it a little bit simpler. So if we have f of x is equal to x plus 2, right? For every single x, there is one corresponding output, right? And functional programming applies the same principle to functions in a program. So each function is treated as a mapping from inputs to outputs. And let's take our previous example that we were looking at when calculating student grades. So imagine we have a function that does this for us instead. So instead of having to manually write out student name equals blah, math grade is equal to something, English grade, so forth, blah, 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 we're just going to create a function that does this automatically. So if we get this function right here, all right. So this is going to be calculating the final grade for a student. So our function is going to be called calculate final grade. It's going to take the input of a student name, which is a string, a math grade, which is a float, English grade, science grade, history grade, and a geography grade. And this function is not going to return anything because we don't need it to, because we've just been printing the answer. So we're going to do the same exact thing that we've been doing before. We're going to calculate the total grade. We're going to calculate the average grade. We're going to determine the final grade by using this if-else little statement area. And then we're going to print the final grade. So one thing that's super nice about this is we don't have to repeat all these variables that we were doing beforehand and basically like rewriting what the final grade is, rewriting what the student name is. We're not overwriting anything. So if we have a section that is for calling this function, we can just simply call the function. So we're going to calculate the final grade for a person named Joe, and we're going to have each of the grades for each of the corresponding subjects, which we basically map up here in the parameters of this function. And instead of having that huge, long 90-line little statement, right? And remember, if we have 20 students, it's going to go up to 500. We just have simple 28. And it's just going to scale linearly with the amount of students that we have, only increasing by 1 each time. So if we call that function again, as you can see, it's going to do the same exact thing. And the great thing about it is, again, if we scale, let's say we add another 6 students, right? Well, let's do 12, right? That's fine. We can even do 24, honestly, right? So again, remember, if we had 24 in the last case, we would have over 600 lines of code. Now we only have 50, which is even less than what was that initial example I gave before with only 3 people. So in this case, if we run this program, right, we're going to get everything that we have expected. And this is one of the benefits of this functional programming example. So we've eliminated repeated code and made the grade calculation more streamlined. And each function call is independent of each other. So we're going to be able to easily extend this as many students as we want, as you can see right here, without changing the structure of our code. And this is a key strength of functional programming. So overall, throughout this lesson, we've gone through this little short journey through the world of programming paradigms, and we're understanding how they form the philosophical underpinning for the code that we do write. And our exploration of procedural and functional programming has set a foundation for our upcoming dive into object-oriented programming. So at a high level, procedural programming behaves like a step-by-step recipe, right? And it's going to be instructing the computer precisely how to execute tasks. And this style is very straightforward and it's very intuitive, but as you can see, as we saw in the example, it's going to be quickly become cumbersome, and with these repetitive and larger, more complex programs, you're going to have to repeat so many lines of code manually, and we want to avoid that, right? And on the contrary, functional programming treats programs like a mathematical function, right? Defining that relationship between the inputs, right? The student name, the grades that student got, and the output, which was that print statement that we had wanted. So by avoiding the state changes and the mutable data, the program becomes more predictable and it's a lot easier to debug. Imagine if we had an issue in that previous code example with 500 lines of code, and it's going to be super tedious to debug that and have to change every other line of code that has that exact same format, right? But with functional programming, since we're reusing that same function, we only need to debug one section, which is amazing for us. So as we move forward in our exploration of object-oriented programming, we're going to build on these fundamental concepts, and we're going to really enhance our ability to write organized, efficient, and scalable code as long as very maintainable. And this understanding is going to make us more versatile programmers ready to tackle pretty much any challenge with the most suitable approach. And yeah, that basically concludes it for this video. I look forward to seeing y'all in the next video. And yeah, keep on coding. Thanks.